Hello everyone. In this video, we will try to see, to determine, scratch that.
Alright.
Scratch it.
Alright.
I'm sorry.
Are you fine?
Okay, I'm ready.
Go ahead.
Hello everyone. In this video, we will determine whether the following function is even, odd, or neither. The function that you and I are going to consider together, it looks like this. F of x equals x cubed minus 5x. To determine whether the function is even or odd or neither, we're going to have to consider several criteria. To remember the rules, to remember their criteria, I'd like for you to think about looking at the following two functions. One of the functions looks like this. Let's have our xy axes. Make sure that I can draw an almost perfect parabola. F of x equals x squared. And the second function, and I'm using these functions because I'm going to assume that by this time you've already seen these two functions. So you've already seen the parabola, and then you will also should have already seen a function that looks something like this. And I'm going to call it f of x equals x cubed. This is our quadratic function, parabola, and this is our cubic function. All right, why are we necessarily looking at these two functions? Because these two functions are going to help us to determine, to remember, to think about what it means for the function to be even or odd. Let's look at the parabola for just a second. For the next few minutes, let's pick some points. How about if we're going to create an XY chart? And let's pick the following x coordinates. We will consider 1, we will consider -1, we'll consider 2, and then we'll consider -2. Okay? Remember that the function value, this f of x, remember that x is our variable, this is our independent variable, and f of x, the function value, becomes our y coordinates when we're looking at the graph. So our question is, if x is 1, what will be the corresponding y coordinate when this x becomes a 1? Another way of saying, let's substitute 1 into f of x. Let's find f of 1. X squared becomes 1 squared. Well, that's a 1. So now we found a point on the graph. When x is 1, y is 1. Let's suppose that x is 1 right here. And y is 1 right here. So when x is 1, y is 1. This is our first point. 1, 1. Now let's consider if we choose the second coordinate for x. Let's consider x being a -1. Well, remember, to find the y coordinate, that's your function value when x, in this case, becomes a -1. So we're looking for f of -1. Let's substitute -1 for x. Remember, x is being squared, so we'll take -1 quantity in parentheses. Let's square it. And when we take -1 as a quantity and square it, it'll give us a 1. Let's find this point on the graph. When x is -1, y is 1. Okay, this is -1, 1. All right. Now, let's see what happens when x is 2. If x is 2, let's find f of 2, so we can find the y coordinate. F of 2, 2 squared, that gives us a 4. So now we found a third point on the curve. When x is 2, y is 4. When x is 2, y is 1, 2, 3, 4. Let's see. 2, 4. Let me move this a little bit this way so you can see it, because I think that point is too close. That way you can see. Okay. Now, what happens if x is -2? -2 squared That gives us a 4. So when x is negative 2, y is a 4. Here's a 4. So negative 2, 4. Okay. Now notice something. It looks like we have a symmetry. If I choose a positive and a negative of the same exact distance, right? Distance here from 0 to 1 is 1. And distance here from 0 to negative 1 is also 1. So if I take the same exact distance to the right and to the left, I get the same exact y coordinate. Look at this. 2, here's a negative 2. Same distance from 0, going up, and I get the same exact y coordinate. It looks like we have a symmetry. Well, another way of thinking about it, if I was strong enough to fold my board along the y-axis, to fold it this way, you'll probably notice that the right-hand side of the curve will lie on top of the left-hand side of the curve. That means this point will lie on top of this point, and this point will lie on top of this point. What we're demonstrating here is a symmetry along the y-axis. So this particular curve has a symmetry along the y-axis. Let's write this down. Y-axis symmetry. Okay. Now, another case to consider directly coming from this particular function is how do we generally express this idea of taking the same amount of distance from 0 to the right and to the left and getting the same exact output. Remember, x is our input. Y, or the function value, is our output. So if I take a positive x and I take the same exact distance to the left, a negative x. If you look, this is a positive x, this is a negative x. A positive x and a negative x. But I'm getting exactly the same output, 4. Or here, a 1. So the function value, the y values, the y coordinates are exactly the same. Here's a rule. When f of x equals to f of negative x, or another way of saying f of negative x equals f of x, when we have this type of a symmetry, this is a y-axis symmetry, not only that, the function that you have becomes even. So as we're considering a function, whether it's even, odd, or neither, if f of x would equal to f of negative x, then this function will become even. Well, not all functions are even. What if this function is not even? Let's see what happens when we have another type of a symmetry. In this case, we'll do something very similar. Let's create an XY chart. And we'll pick exactly the same x coordinates. 1, negative 1, 2, and negative 2. Okay, exactly the same x coordinates. Now, we're going to consider when x is 1, what is the function value? And again, remember that the function value becomes your y. It becomes your output when these are your inputs. X is independent and y is dependent variable. So let's see what happens. What is f of 1? Let me write it this way. I know I've said it several times, but I haven't had a chance to write it this way yet. F of 1, that means substitute 1 into this x. This becomes 1 cubed. I'm writing it too close. I'm sorry, you guys. Let me write it a little bit further apart so you can see it. 1 cubed equals 1. All right. So far it looks the same, isn't it? But let's see what happens when x is negative 1. Let's find f of negative 1. Well, remember, this 1 is negative. Make sure to put parentheses around it. It's an entire quantity. Let's now cube it. Are you going to get the same exact output? Well, negative 1 is being raised to an odd exponent. The result is negative. Quite different result. Hence, function looks different, you see? So let's keep going. Let's see what else we have. What happens when x is 2? All right, let's find what is f of 2. again, this is what I did. I took x equals 2 and substituted into this x. So now I have 2 cubed. 2 cubed is 8. Okay, output quite different. You see? Positive, but different positive. Now let's look at negative 2. Negative 2 cubed. I'm looking for f of negative 2. I substitute negative 2 into this x. Let's see what happens. Negative 2 cubed, the result should be negative because the exponent is negative. The negative is inside, the exponent is odd. The negative is inside the parentheses. The result is negative 8. All right, let's label these points on the graph. Let's see what happens. When x is 1, y is 1. Okay. When x is negative 1, y is no longer 1. It's a negative 1. You see, we no longer have this y-axis symmetry. You see, if I fold this paper, if I was strong enough to fold my board along the y-axis, this point is not going to lie on top of that one, you see? Now let's keep going. Let's label a few more points. When x is 2, y is 8. All the way over here. And again, I wrote it too close. So let me do it this way. Let me rewrite, because I want to make sure you see all of these points. F of x equals x cubed. And remember, this is your y values. These are your outputs. So let's label this point 2, 8. But if I choose x negative 2, okay, now look, y output is negative 8. Okay, again, if I were to fold my paper along the y-axis or my board along the y-axis, this point will not lie on top of that one. So this is not an even function. This particular function doesn't have a y-axis symmetry. So what does it do? Well, imagine that I have a push pin. Okay, so imagine that I have a push pin. And what I'm going to do is I'm going to rotate this curve against the clock. The clock ticks this way, so I'm going to rotate it against the clock, counterclockwise, this way. Imagine I have a push pin, and I'm going to rotate along or against the clock, and notice what will happen. Eventually, this point will move here, and as it keeps rotating, this point will be here. As I rotate, this point, 2, 8, will eventually lie right here, and negative 2, negative 8 will eventually lie here. You see? This is called a symmetry over a very special point, and I'm going to label it right here. I'm going to call it origin, 0, 0, origin. Remember, I took my push pin and I imaginably stuck it right smack in the middle right here where the x-axis and the y-axis cross perpendicularly, creating a 90-degree angle. Okay? This push pin was stuck on 0, 0, right? This is where I pushed it. And this is how I rotated it. Okay? This particular function has a symmetry over the origin. Let's write this down. Symmetry over the origin. Okay. If a function has a symmetry over the origin, this function is going to be called odd. Notice to remember, notice how odd starts with the letter O and origin starts with the letter O. So if a function has a symmetry over the origin, it's going to be odd. Well, we see it pictorially, right? We have a graph. We see it graphically. Well, let's look at the rule. And the rule deals something like this. Notice what happens. If I pick an x to the right 1 unit, to the left 1 unit, to the right 1 unit, to the left 1 unit, do you see how I have opposite results? A positive gives me a positive. A negative gives me opposite of the positive. You see, it's opposite of the original one that I received. When I substituted 2, my result was a positive 8. But when I substitute x that's negative, my result is opposite of the original 8, of the original output. Let's write this down. Notice I'm going to take a positive x and I'm going to take a negative x. Here, I took a positive x and a negative x, but my function values were the same. You see? Here, when I take a positive x and a negative x, or here, a positive x and a negative x, let's see what happens to the function values. Something must happen to the function values, right? So we're going to have to determine, okay, what happens to the function values when I substitute positive x and a negative x? The function values go something like this. Notice, when I substitute a negative, I'm going to get a negative output, right? Okay, this f of negative x equals to negative original f of x. Let's do it again. Notice how I took x positive and x negative. When I took a negative x, my result was opposite of the original f of x. Okay? That means if I take a negative 3 and a positive 3, my result should be the same but different signs. Okay? Let's see what happens to this function. By the way, if this doesn't work, and if this doesn't work, then you have a function that's neither odd nor even. Let's look at this example. Okay? We know f of x. F of x equals to x cubed minus 5x. We know f of x. Okay? Let's see what happens when we find out what is f of negative x, because we want to know if they're the same. Let's look at f of negative x. Okay. Remember, when I took a negative x, I substituted this negative x into this function. You see? So I'll do the same thing. I'll take this negative x and I'll substitute into this function. But this time I have 2 x's to substitute. So I'll substitute for all of the x's. Negative x quantity cubed minus 5 times negative x. So this negative x was substituted here, and it was also substituted in here. Okay, let's see what happens. F of negative x. Okay, I have negative, and I'm cubing it. The result is negative. Negative times negative is positive. So now I'm going to compare. I have my f of x. Let me underline it in pink. I have my f of x. Here's my f of x. Okay. I also now have my f of negative x. Here's my f of negative x. So the question is, are they the same? So the question that we're asking is f of negative x exactly the same as f of x? Well, let's try. Let's rewrite. F of x is x cubed minus 5x. Is it the same? Is it equal to negative x cubed plus 5x? No, they're not. They're completely opposite, you see? They're not. They're not the same. So that means that this blue function, x cubed minus 5x, is not even. It's not an even function. All right? If it's not even, it could be odd. Let's see if it's odd. Need a little bit more room. So let me erase and start again looking at f of x, f of negative x, and then negative f of x. So we can now see if this function could be odd. Okay. All right. Now, for the function to be odd, we're going to have to look at this. Let's try. F of negative x. That's what you did in the previous step. So let me rewrite f of negative x. F of negative x is negative x cubed plus 5x. This is what we did just a few minutes ago. Now, our goal is to find out if it equals to negative f of x. So now I'm going to take f of x, and I'm going to multiply by negative 1. That's what that means. Positive, you see? Negative, positive, negative. I'm going to take my original function, x cubed minus 5x, and I'm going to multiply it by negative 1. Remember, we have to distribute, use distributive property. Negative times positive is negative x cubed. Negative times negative is positive 5x. All right, so now let's see. Let me get my red pink marker. All right, now let's look. This is my f of negative x. This is my negative f of x. This is where we substitute negative x. This is where we took the function and multiplied by negative 1. So this is here, and this output is right here. We want to know if these two outputs are the same. So let's compare them. Is negative x cubed plus 5x the same as f of negative x? Negative x cubed plus 5x. Are they the same? They sure are. They sure are. So that means that this function is odd. This is an odd function because it has a symmetry over the origin and it obeys this particular property. And we're done.